we continue our discussion on the impact of this security protocol. The security protocol just now we studied is TLS protocol. In the last lecture we studied is TLS protocol. What is its impact on server performance? So, I would like to let you know that if you are going through this lecture, it is essential that you have covered the previous lecture. So, otherwise it will be difficult to follow this one, because here simply we are considering one numeric example. So, let us look what is the overhead due to TLS protocol. Through one example we will be understanding various situations and to see that whether we should be actually encrypting the entire site or encrypting a part of the site, or we will be using some kind of hardware for this encryption process, and what is the impact of doing all this through trying all this combination of finding out the most beneficial way of implementing this security protocol in your e-business site. So, let us try to go through this example. As we have told you, this TLS protocol actually increases the overhead. So, this increase in round trip time is it happen due to the transfer the multiple time handshake, the handshake that the data before the actual data actually sent, many other data elements are sent and some kind of cryptographic algorithms are carried out. So, last class we discussed what are the processing time involved at client and server end. This includes handshaking time plus bulk data transfer time. During handshake, both client and server do different kinds of operation. During record protocol, which is for bulk data transfer, server encrypts it and the client decrypts it to read that. So, let us now see one example. What is the effect of this TLS protocol on web server throughput? So, while talking about this web server's performance, we have understood that in a e-commerce setting, if your server does not perform well, if the response time is too slow, then people will not be staying in your server, they will be immediately moving to some other place. So, therefore, would like to see what is the impact of such security protocols on server throughput. So, now look at the definition of how, let us have a numeric value to compute the server throughput. The server throughput is equal to the number of completed queries per observation period. Number of completed queries, you mean the number of pages, the number of page requests sent to the server and the response sent back by the server. So, this is about the number of responses sent back by the server. So, this is your server throughput. So, this throughput is equal to 1 upon the service demand by the clients, where the service demand is the average response time per service request. So, web server throughput is equal to 1 upon service demand at the bottleneck device. So, here I would like to remind you about your web system architecture. So, to understand the concept of bottleneck device, bottleneck resource, let us try to understand what is the web system architecture. In fact, we have already studied about this web system architecture in the previous one of the previous lectures. Just to remind you once again, I show you about the web server architecture. when the client connects to the server, three things are now involved. One is the web server, which in turn connects to the application server, and application server connects to the database server. So, it is database server, application server and web server, and sometimes this web server and application server will be contained within the web server, and database server might be different, or sometimes in fact all the time this will be a logically different entity and probably physically different as well. Here also they are logically separate entities, and sometimes they can be physically separate as well. So, out of those resources, we will be like to find out where is the bottleneck. And in earlier literature also I have told you, when there is a slow response time experienced by the client, it may be due to the fact that the client machine itself is slow, the network, the service provider through which the client connects, it may be slow, then the network over which the packets are going, the network might be congested and might be taking time, then the ISP, the internet service provider at the end of the server may be not be performing well, and finally the server. So, server in turn connects to database. So, all these entities who are involved in this web transaction are responsible for slow response time during web transactions. So, therefore, if we adopt these security measures, we have to find out who is now the bottleneck device. Now, which is the bottleneck device? The bottleneck device is the one with highest service demand. Now, what is highest service demand? Maximum time is taken at the bottleneck device. Even if the other devices perform well, because of the bottleneck device, the system will be slow. So, let us look at this example. Suppose you are trying to send the files and the average file size requested by the client is some bytes, then average CPU time for accessing the file at the server when the secure connection is not there, it is this much, then average time for a disk access is 0.01 second, then average network delay is given here 0.001737 second. Now, this is because when the packet gets transferred over the network, this is the for the disk access. Disk access time means from web server when you access the database server, that is a disk access time. So, your bottleneck device can be storage, network, client or this thing, and here the network delay, disk access delay, and then CPU time for accessing a file at the server when it is not going through the storage, it is this much, and this is the file size. Now, look at our aim is to find out what is the server's performance when there is performance in terms of throughput, when there is insecure connection, there is no TLS, when all the pages are secured, then the secure connection for a part of the site and using some cryptographic accelerator, which is some kind of hardware device, and using the cached session states. So, how it is going to affect the server's performance, that we are going to see. Then throughput with insecure connection. If you look at this data, which device takes more time? It is the disk. So, disk is the bottleneck device when the system is insecure, the TLS protocol is not implemented. So, what is our throughput? Throughput formula was 1 upon the bottleneck. Let us look at the throughput formula. This web server throughput was 1 upon service demand at the bottleneck device. And what is service demand? Average response time per service request. So, average response time per service request for this particular example was the highest in case of the disk. So, therefore, the throughput is 100 requests per second. It cannot go beyond this. Now, let us see if TLS is implemented in the whole site, what is the situation. If the TLS is implemented, besides bulk encryption, some handshaking also takes place. So, it is the time for handshaking and for decryption and verification, that of course, there is one step called verification to verify whether the content has been modified in between or not. Now, let us say, and as I have told you already in the one of the previous classes, the time actually increases with that of the key size. Now, suppose for the time for handshaking is when the key size is 512, 768, 1024, the verification time for server certificate are this much. Then the encryption of the master secret, try to remember what we studied during this handshaking procedure, TLS handshaking procedure. There was exchange of server certificate, there was generation of this master key at both, there was encryption and decryption of the master secrets, and there was time for key generation. So, including all these times, the total time for the client side handshake has been this, as you can see how the time increases with the key size. Then once this is done, then the encryption and decryption of the message digest at both the ends has to be done, because the data has to be sent along with that message digest. So, for encryption and decryption, it is this is the time, this is in terms of megabits per second. So, this much of bits get generated at both the ends during this encryption, decryption and message digest generation process. Then this is the values for various key sizes. Assuming that you have a 1024 bit key, RC4 and MD5 algorithm, here we are using for encryption decryption 3 options were available: RC4, DES and TDS. These are what? These are what? These are actually the bulk encryption. See, during handshaking your key exchange takes place. After your key gets generated by sharing some secrets. Then after the key gets generated, using that key the bulk data transfer has to take place. So, for that bulk data transfer, some encryption decryption algorithm has to be used. So, 3 options are given here. Look, during handshaking procedure, which algorithm will be chosen is decided. Similarly, for message digest generation and verification, why it is done? This hashing, this MD5, SHA, SHA1, they are all hashing algorithms. What for they are used? They are used for what is the use of this hash function? Hash function helps in authentication, non-repudiation and the data integrity. So, whether the right data has during this process, the encrypted data which has come, whether the right data has come or the encrypted data on its way has got modified, that has to be checked. So, again some hashing is used. So, there are 3 options were available. So, with these 3 options, based on the negotiated algorithm for encryption, decryption and hashing, assuming that RC4 for encryption and MD5 for hashing is used, the total service time at the client is equal to time for handshaking plus time for decryption of the data which is sent by the server after the server is authenticated during handshaking procedure. So, this total time is actually the time for handshaking. This time was in millisecond. Then the other one, this one was the conversion rate in terms of Mbps, and total file size, average file size that we discussed here was, average file size was this much of byte, 16,385 bytes. So, that byte now need to be converted to during the message digest generation. So, this was in bytes. So, number of bits it was converted and it was in megabits per second. So, that is how the total time turns out to be this much. These are simple calculations, you can do it yourself, and this much time gets this thing. Now, at the server side again similar operations happen, and during this handshaking I am not going to the details, but here again there is a decryption of the master secret which with its own private key, and we have one of the earlier lectures I have told you this private key operations are bit costly. So, more time is taken by this key generation same time, and this is the total time. So, assuming again that these three encryption algorithms and option for these three decryption algorithm hashing functions are available, and assuming that RC4 and MD5 are used, and this is the time taken for handshaking, and 10 because the key that was used earlier the same size key you will be using, those assuming that is 1024 size key is used for handshaking, this is the calculation is again same. Now, this is the total time. So, if this is the total time, what becomes the bottleneck now? Server's disk time remains same, client's time has increased, network remains same, this is now server time. So, earlier when the server used to be the bottleneck device, now client has earlier when the disk for data access was used to be your bottleneck device, now your server has become bottleneck device. And what is the decrease in throughput? Earlier it was 100 requests per second, now it is 19.3 requests per second. So, it is 20% of the throughput without TLS. So much slower it is now becoming. So, therefore, it is advisable that the whole site need not be actually encrypted. By whole site we mean all the pages, a particular website contains thousands of pages. So, instead of encrypting thousands of pages, all of them, because it is so costly and it will make your server's response time go down so much, your throughput will decrease so much. So, what you will be doing? You may like to partially encrypt a part of the site. So, partially encrypt the site, only the important pages will be now encrypted. Okay. Now, you come to a different scenario. Scenario is you assume that there is 40% of the requests are for the insecure documents, and the service demand at the CPU is the weighted average of the service demand for both secure and insecure document. So, your 40% is for insecure document and 60% is for secure document. For insecure document, your disk was the bottleneck and for secure documents your server was the bottleneck. Now, if you take a weighted average of this, you still get the CPU, I mean you see you are getting the weighted average at the server, and this was already the server's throughput for the time taken at the server when for a insecure document, and this is for a secure document. You are taking the weighted average of this. Now, it is you find still this time is higher than the disk access time, which was 0.01. So, CPU or the server is still the bottleneck. So, therefore, your throughput is 1 upon the bottleneck's this thing. So, it turns out to be 31.43 pages per second. So, from 100 pages per second, when you secured everything in your site, you was able to send around some 19, what was exact number, the 19.3 requests per second you were able to serve. Now, it has, because you did not make all your documents secure, only 60% of your documents are now secure, it has now increased so much. So, therefore, while working in a while securing your website, you should be very careful that you should unnecessarily secure, unnecessarily make arrangements for making all the files in your site secure, because there will be some files which are public enough and can be seen by everybody. So, they need not go through the secure connection. Okay. Now, if you look at the use of a cryptographic accelerator, which is a kind of math processor, and assuming that it will increase the handshake protocol by a factor of 50% and it is used by both client and server, the service time at the client is these calculations are like earlier, has now this much, it has become now very fast. Service time at the server CPU has also decreased. Then the bottleneck now becomes the disk. So, by using a hardware device for calculating this, doing the security operations, your maximum throughput remains as it is. So, therefore, we can conclude that using a hardware device is a good option. It will make your these things faster. Then using the cached session states, if we, while discussing about our handshaking protocol last time, we were showing that it actually you have to follow two paths, either you keep the session keys, and session keys expire within a they have a life and they expire, and within when they are live you can actually use the session key. So, if we use session key, assuming that 60% of connections are for the cached states, you can increase the span of their life of these session keys. So, if assuming that 60% of the connections are secured, now the service time at the server is recomputed, that is without that math processor, you can do the computations yourself, and you can find that now the bottleneck, you can now find that the service time at the server is now increased and it is higher than that of your disk. So, therefore, the throughput is reduced. So, we can conclude that if you appropriately adjust the life of your session key, then possibly you can have your throughput increased. So, with this example we get the idea that how the security protocols need to be managed, so that your performance of the server is not hampered so much. With this we finish this lecture. Thank you very much.